Welcome everybody to the group exhibit for hydrogen fuel cells and batteries here at the Hanover Fair 2017. Please, I welcome anybody to come in, sit down, enjoy a complimentary beverage. My name is Michael Sinclair and I'll be your moderator for this next discussion. I'd like to remind you guys that audience questions are welcome at any time. Just raise your hand and I'll come bring the microphone to you. Here to talk about hydrogen energy storage projects standing alone without grants or subsidies is the Senior VP of Engineering from Proton OnSite. Please join me in welcoming Mr. John Zagaja to the stage. Thank you.
How are you?
Thank you, John, for joining us. So if you wouldn't mind, please beginning by introducing yourself, your company, and the products and the markets that you serve.
Sure. Yeah, I'm John Zagaja. I'm the Senior VP of Engineering for Proton OnSite. Celebrated last year, actually, our 20th year in business as a premier PEM electrolyzer manufacturer and component supplier. We offer a range of products from the laboratory scale, so a few hundred cc's per minute, up to our recently introduced product platform, that's the megawatt, which we offer in two building block sizes, both the 1 and 2 megawatt scale, capable of delivering up to 400 normal meters per hour.
Very good. And what parts of the value chain do you provide? The technology, do you also offer kind of the engineering and procurement side, the installation and O&M?
Yeah, absolutely, across the entire range of our products. So again, our core competency or technology that's evolved over the 20-year period has been in the cell stack, so unique to the PEM manufacture and cell stack design. We integrate that into a variety of platforms, again, starting with a very small, up to and including what is an 8-stack, 2 megawatt system.
Okay. So what does Proton OnSite see as the largest opportunities for growth in the market today?
Well, certainly, and you see it all around us here, is on the energy storage forefront. So with our recently introduced, again, megawatt scale products, I think it's really testament to what we see as an emerging market for hydrogen, since it has such broad utility for fueling, for industrial gas supply, et cetera. And with, in particular, the glut of renewable energy, I should say excess or stranded renewable, there's a real business case to be made around having that hydrogen available at a low cost, and we'll talk a little bit more about that coming forward as a solution to that problem.
And okay, that's all very interesting. So a lot of it's power to gas, yes, for grid scale storage applications long term.
Correct.
I guess in this the common applications would be to smooth out the seasonal effects of for renewables, and smoothing out the generating capacity, I guess, over the year.
Seasonal and daily, for instance, right? So certainly with the demand not matching the supply for many of the wind and solar renewable sources, that available energy or that capital investment that's already put forward to the renewable generation, if you will, is unavailable. So again, providing a stored hydrogen solution as part of that to take advantage of that from a value chain standpoint is what's important.
And what would you describe are the biggest challenges that the industry faces?
So the biggest challenges I think we face right now are cost, and that's both CapEx and OpEx. So from an OpEx standpoint, certainly you need to have a reliable product, and we'd like to think that the 20-year history we have with the product base that we have has helped establish us as having that reliability that's required to keep the operating expenses as a minimum. On the CapEx side, it's a little more challenging, although as I'll point out, from the inception of our early products to the megawatt product, then we've seen a reduction on the range of 80% in the CapEx. So the dollars of CapEx per unit output of hydrogen has reduced by 80%, and we have a path we believe forward to actually reduce that further and actually make that product more competitive.
And what are the main drivers of those costs? So you divide it into CapEx and OpEx.
Yeah.
Elucidate me on what are the main component costs and for both of those factors.
Yeah. So I'll say we'll start with the CapEx side. The cost of the megawatt system, if you will, is equally divided between the cell stack, the balance of plant, and the power supplies at this point. So we actually see opportunities across all three to reduce that. So there's work underway to significantly reduce the cost of our cell stack. In addition to that, matching that cell stack with the available rectification or power supply solution actually offers a better match in terms of cents per watt to generate hydrogen. On the balance of plant side, we'd like to think that the economies of scale, so when we're in the 1 or 2 production quantities, we believe that in the tens or hundreds, we could actually reduce significantly vis-a-vis the supply chain and lessons learned across the way.
You mentioned that you've seen 80% reductions in scaling up the size of the equipment. How much more room is there for further cost reduction?
We believe it's significant. We're somewhere at this point in the $1,200 plus per kilowatt of hydrogen generation at the megawatt scale. We think we have a good path at this point with the existing platform to get under 1,000, and then in our next generation platform to actually get lower than that.
And how close are we to standalone viability of these types of technologies? Is getting under 1,000 a big milestone in terms of the viability in the market right now?
Yeah, I think the industry believes that. Yeah, certainly. I think getting down to the, I'll say 700 or 800 is probably a necessity in the near term. At least that's what we found from the business cases that have been run.
And on the OpEx side, what does it take to run one of these facilities?
What do you mean to run one of these facilities?
Yeah, I just mean what are the common components that need replacing or need to be maintained, et cetera?
Actually, the maintenance is fairly low, especially with the PEM. So there is no liquid electrolyte. We have demonstrated performance of our cell stacks in the, I'll say, the 60 to 80,000 hour range is the nominal performance. It's really a pumped water system when you think about it. So some filter maintenance, if you will, change out of deionizer resin guard bed are really all you need to do on a regular basis. Okay, so
energy storage, hydrogen storage really is still quite in its infancy, I would say. How does Proton OnSite sustain itself as the industry and the demand grows for the technology?
Yeah, so I think, as I've said, we've grown up with the smaller scale projects are ideally suited for industrial markets, and it's quite a good market niche for us at this point. So I think we continue to realize revenues from those industrial products, again, at the sub-megawatt scale. And we take the opportunities we can in the energy storage market with the larger scale systems, but we continue to drive costs down to make those viable as well.
So I read in the news that Nel recently acquired Proton OnSite. That was just in this past February, which I understand created the world's largest electrolyzer company.
Yes, and it will. So you say acquired. We entered into an agreement or a negotiation with Nel at that point. It hasn't been formally closed. We're anticipating that shortly at this point, but certainly we're excited about that acquisition. We believe the merger has a lot of good synergies associated with bringing our PEM technology into Nel, who's got obviously the KOH technology at a larger scale. They have a lot of inroads into some of the fueling and energy storage applications, which are ideally suited for the PEM technology in our 1 and 2 megawatt platforms as we has them. So we're certainly excited about it.
What is this new kind of joint kind of acquisition? What does it say about your competitive position in the market, the viability of the technology? Does it make any statements about Proton OnSite?
Well, I think it certainly does. I think it's again, it's a recognition of the heritage and performance of the technology that we bring. I think it also highlights the importance of PEM as one of the I'll say desired technology going forward with for hydrogen production. So I think that broad recognition, and again the synergy it brings with our collaboration with Nel going forward is important.
Maybe just take a high-level view for a second and just explain to me, I'm fairly new to fuel cells, but PEM technology, what is PEM technology and specifically what are its strengths?
Okay, so PEM technology at its base is a solid polymer membrane. It does not, traditionally electrolysis has used liquid electrolyte systems. PEM offers, again, a solid state solution to that. The way that The way that we configure it in our cell stacks allows you to operate under high differential pressure. So we actually generate all of our gas at, I'll say 30 plus bar at this point. That's the hydrogen. It's full differential to the oxygen. So the oxygen is at ambient pressure. That allows the systems to be run, I'll say, because we have high pressure hydrogen and ambient pressure oxygen, all the sensitivities around an oxygen system at pressure, the associated safety risks, the costs associated with them are minimized or eliminated. That's common to all of our systems at this point. So high pressure hydrogen, low pressure oxygen is a simple balance of plant, is a reduced cost offering for our products. And again, it's a benefit I think we've enjoyed over the life of the products that we have.
And when you're storing hydrogen for these energy storage projects, what are the big engineering challenges there? I mean, how much hydrogen diffusion do you get, et cetera? How long can you store hydrogen for?
Well, it depends on the storage technology for sure, the particular challenge, again, I think like so many other things at this point, is cost for the pressures that we're talking. Some of the technologies are fairly, I'll say, esoteric and expensive. So the combination of lightweight and the ability to store at high pressure is not inexpensive. So you can do it in large steel tanks, but much more so attractive to this industry with some of the carbon overwrap tanks that we see around the corner here, and is what people are looking forward to. But we need to get the cost down for those.
For large scale grid projects, I guess it wouldn't so much lightweight wouldn't be a huge factor, I guess. Is that fair to say?
Yeah, it's not much of a factor.
All right. The other thing I was reading about is you've announced a 13 megawatt electrolyzer deal in China. Could you tell us a little bit about that project?
Sure. So we introduced the product in early 2016, and later in 2016 did receive our first order from China. It's for a total of 13 megawatts. So they're individual 1 megawatt systems. The first 3 of which are currently in production and will be delivering later this year. With the balance in 18 and probably some in 19 at this point. They'll be, I'll just say they're going into the Guangdong region in China. They're going to be used for fueling buses, which they have in production there.
So why fleet vehicles? Why is this what market demand drew? Like, what's the advantage for fleet vehicles for hydrogen technology?
Well, certainly in this particular application, again, it's nice to have a centralized generation facility. Again, and it's ideally suited, as you point out, for a fleet vehicle. So I fuel the vehicles at night. I can drive them around during the day. So there's an advantage there.
So the title of the talk is Hydrogen Energy Storage Project Standing Alone Without Grants or Subsidies. So how is this project funded?
So it's a private group in China. It's the same group that actually is coordinating there's Ballard fuel cell buses that are there. So they're overseeing the building and piloting of production facilities there for the buses and the fuel cell power plants from Ballard. So it's actually the same group that has orchestrated that is financing this project, that's providing the hydrogen infrastructure solution to that as well.
Are there any audience questions at this time? No, that's fine. How would you describe the difference in demand for hydrogen technology between Asia? You're from the United States and here in Europe.
Certainly more so, at least in the industrial product lines to this point, the availability of delivered hydrogen in the U.S. and the associated costs makes it a harder market in the U.S. So primarily the industrial products we sold into niche markets where safety or convenience of having on-site generation was more than the associated cost with the delivered. So therefore, when you look at our industrial products, the primary markets for us are in areas where delivered hydrogen isn't as readily available, and those applications are there. So you see it for power plants in the Middle East and Asia, for a large draw for us, and somewhat in Europe at this point for some of the power to gas projects, some of the demonstration projects. So more in Asia and Europe than in the U.S.
With power to gas, just a question occurred to me is, how will that industry ultimately look? Will it be large-scale facilities or more of a distributed approach?
Depends who you ask, right? There seems to be two schools of thought there. So certainly, I've seen penciled out in many cases the 100 megawatt plus facility. Certainly, it probably at the generation of technology that we have, the 1 megawatt or 2 megawatt building blocks, it probably doesn't make financial sense to build out that way. So we've had actually more interest in, I'll say, smaller distributed type facilities at the 1 or 2 megawatt level, which we think, again, our product is ideally suited to match into.
And why would that be? Why is it ideally suited at that scale?
It's just the way that the business case is penciled out for this. It's the availability of the renewable asset at that scale, the proximity of it, and I'll say the ease in putting up a small scale electrolyzer as opposed to building a large facility and getting access to the power locally.
How big a concern is security for hydrogen storage?
That's a good question. It frankly is not one I've thought about. I can imagine it's not. Yeah, no, it's all right. I can imagine it's the same as any facility. Hydrogen, of course, is used extensively in commercial applications in a delivered sense, both liquid and pressurized. So I'd expect it would be no more of a risk or hazard or security risk than it otherwise is today.
Okay, if there's no other questions, for more information, I'd like to direct you to the Proton OnSite booth, and it's located at C70. Please join me in thanking John Zagaja for this conversation.
Yes, thank you. And please come by and see us around the corner. Thanks.
Thank you very much.
All right. Great, thanks. It's good.